Hi, I'm Aaron Hand. I'm out at the SPIE BACUS Photomask Technology Symposium in Monterey, California, where I was able to catch up with a few of the panelists from the MCA BrightSpots Lithography Forum. These industry all-stars had a lot to say about advanced lithography, and here's a bit of what they had to talk about. I'm with Paul Ackmann, Engineering Fellow, Advanced Reticles at GlobalFoundries. Paul, regarding 193 immersion lithography, does the use of complex OPC and source mask optimization extend the life of ARF pretty extensively?
At this point in time, yes. We see that being used starting effectively at 28 nanometers. We see the immersion tools lasting well beyond 20 nanometers for certain things. And we see the ability to get the development of the new technologies in place at an earlier time using the new scanners, the new OPC schemes, and also the new illuminators. So all those things play together and allow us to progress on the technology node still using the 193. The immersion capability has really helped extend the life, and without an alternative lithography that gives us a methodology to continue to develop the technology that our customers want and the timing they want it in. And so if I was to say I had to wait for EUV or direct write or nano imprint to be ready, then I would delay my technology node. As it does now, we're continuing to move the technology node down by using more advanced resists, more advanced OPC, more advanced illuminators, and all the other things put together to allow us to get the products that the customers want when they want them.
Okay, so EUV masks seem to be a pretty big issue for the industry right now. Is the industry going to be able to get through the challenges that they need in the time that they need to by the time ARF runs out of steam?
I wouldn't want to look at it as a ARF running out of steam. It's when is EUV ready and how do we get it into the technology. Mass defectivity is a big concern, and that's the area, since it's reticle related, I worry about that a lot. If I was to put it in today, if everything else was ready, I'd be at a 45 nanometer or a 32 nanometer node. So the defectivity that you have at that level is a lot easier than defectivity level you'd had at 11 nanometers. And so when we start looking at things, we've got to really look at what it takes to make a perfect reticle in the time that you need it. And so as the industry works collaboratively at Semitech and other places, we're really working on trying to make sure that the blank is good, that the multi-layer film is good, and that the ultimate patterning and everything you need is good for the technology node where you'll put it in. And so as we look at the technology, the difference here really between the 193 transmissive reticles and the EUV reflective reticles are I now have to worry about any surface issues on the substrate, i.e. the low expansion glass. I have to worry about any deposition type defects that I might have on the multi-layer film, and then I have to be able to check where those defects are and then be able to fix those and then be able to ship the mask out. So there's been a lot of work being done, and Intel presented last year and other people have presented about trying to shift the pattern, because the idea of getting a perfectly defect-free mask with nothing on that is probably going to be very difficult. But there are many ways to mitigate those defects, either by adding extra pattern or by shifting the pattern a little bit, and that would allow you to use a mask that technically would have a couple of defects, but would, by moving those patterns, they end up not printing. And so there's going to be a lot of effort done over the next couple of years to really make sure that that kind of activity can actually be executed in a manufacturing mode. When you look at the first production tools being delivered, so you know the EUV is going to happen. I mean, if you look at it now, we're committed to making that happen. As you see the one by one the different problems being solved, ultimately the mask making becomes the issue that we got to make sure that that is not the stopping point. If the scanner suppliers can give us the tools to run, it would be very bad if we can't deliver the reticles that work. And so ultimately I'm going to worry about that a lot.
Okay, so you think these mitigation methods, though, will help alleviate the time frame concerns?
I think that's one of the methodologies. I think still working with the suppliers to get defect-free masks is still the way we want to go without the mitigation. And it also, remember, we have to get down to the size. If I can get the EUV earlier in the technology and insert it earlier, then my defectivity is less critical. If I use it on a contact layer, say, versus a gate layer, then the percent open. And so all those mitigation strategies play into how you get EUV into the manufacturing environment.
Okay. Well, thank you very much for joining us today, Paul. I'd like to thank the panelists from the MCA BrightSpots Lithography Forum for their time and comments. I hope you'll join these experts in an online discussion beginning September 15th and running through September 22nd. I'm Aaron Hand with the MCA BrightSpots Lithography Forum.